Welcome to Monitor Your AWS Generative AI Stack with Datadog. Before I begin, let me introduce myself and David. I'm Ryan McLean. I'm a senior tech evangelist at Datadog, and I've been with Datadog for 4.5 years at this point. Prior to that, I was an engineer at Samsung, and I've been using Datadog for more than 10 years. How about yourself, David?
Hey everybody, I'm David Marsh. I'm a solutions architect at AWS, and I work primarily with our nonprofit customers. I'm a generalist SA. I've been here about 4 years, and I've been working with Datadog for at least a few of those years, helping our customers integrate both of these tools.
That is awesome. Now, I think we can all agree that when I say the excitement around LLM tech is more than a passing trend. However, given how often we hear the terms like AI, Gen AI, and LLM, it can feel like not using AI in your business is just background noise, basically. So you hear about this all the time, but you're not sure kind of how it fits. That being said, integrating generative AI and language models into your applications enables you to build powerful tools, data analysis, intelligent search, and text and image generation. So there's a number of tools that you can use to leverage Gen AI and scale it according to your business needs. There's specialized technologies such as vector databases, development platforms, discrete GPUs being necessary to run many models. And we're lucky to have AWS joining us today because they've got all of that and more. But if you're new to Datadog, I just want to give you a quick introduction. So Datadog is a monitoring and analytics platform that helps companies improve the observability and security of their infrastructure and application. And Gen AI is no different here. So I just want to quickly go over the Datadog platform as a whole, because there's a lot going on. Now, you don't need to study this slide, but there's a lot happening here. So basically, you could think about something like the dev pipeline, for example. So let's assume that you've got a new piece of technology that you want to land into a brownfield install. That's to say that you've already got a digital domain, you've got servers out there running your business, that kind of thing, but you want to add something new to it. And the question is, where in this pipeline would it land? So obviously you have to go from dev to staging to prod, but at what stage are you with Gen AI and your development? Now, you don't need to give me an answer. I think everyone's at different maturity levels, but what we're going to talk about today is how you would integrate these new or emerging technologies into things that you already have. But before we do that, I want to talk a little bit about building applications on LLM stacks and why this may be important to you. So to think about how this may fit into the puzzle pieces of the digital domain that you have, it's important to think about how we got here and what are some of the problems that we were solving prior to this stage. So this is a slide that we've been using for almost 10 years now at this point in time. It's still true. And the basic point here is that when you lean into tech innovation, you're faced with an explosion of complexity. Now, when we're talking about AWS or cloud technology, at the time when cloud technology was new, what we were trying to address is that lead time for getting servers, or maybe the amount of time to configure and spin them up, or times when you had like a boom time, let's say something like a Black Friday, and then the lull of sales after that, the lull of traffic after that would mean that you'd have to purchase something and then figure out how to reuse it temporarily until the need came up again, basically. So there's that little step function, basically. You've got a big jump, and wouldn't it be nicer if you could just gradually lean into it? And the same thing applies to some of the old tech that we used to use. When we're thinking about few vendor suites and a smattering of software companies that can sell you software. In the past, I've been in tech for a while. In the past, it might have been something like a software vendor that would handle your ERP as well as maybe your Office documents, that kind of stuff. These days, we've got a proliferation of software companies as well as open source tools that we're using. And as we add more tools and add more vendors, this can become more and more complex. Now, couple that with your frequency of releases, if you're thinking about something like a DORA metric, like how often can you deploy, or the mean time to deploy a release, as opposed to the frequency of release, like how long does it take, as opposed to how often are you releasing. And in the past, this may have been something that you did on a yearly basis. So you might have a new operating system, for example, every year. These days, it might be that if you're looking at the operating system on your phone, it could be multiple times a day that you're having an update if it's for something like a security fix. And as you're updating these pieces of software that underlie what you're trying to push out to your clients, it means that your integration tests, of course, become more complex. Now, between each of these graphs is a multiplication symbol, because it's not that we're adding complexity, it's more like a network effect. So when we're adding more vendors, but we're also adding more deploys, it means that more things need to be tested on a regular basis, which makes it more complicated. Now, on top of this, when we're talking about things like physical hardware in the past, it was less complicated. When we move to the cloud, we might have more cloud instances. And then as we start to worry about startup times, when we're talking about pushing out those features or rapidly being able to deal with traffic that's coming in, we may deal with smaller pieces that we're delivering. So containers or serverless, or maybe even microservices. Now, couple that as well with the number of people involved as we shift left. So in the past, this may have been more of an ops concern, which is sort of where I come from, or DevOps, which is a lot of my experience. But then you get into things like business and DevOps, if this is a platform solution or a BI solution or what have you. And then on top of this, you might have DevSecOps. So security has now become a concern as well for multiple teams. And the amount of people involved in just these concerns to push things out to production become increasingly larger. And as they become larger, this is a real human network effect as well, coupled with all of these changes that are happening at the same time. Now, all this to say that that's where we are at present. And then, of course, we layer on top of this emerging tech, which some of these are just the Cambrian explosion of large language models, for example. Or if we're thinking just about training our own or using other vendors' solutions, such as AWS's, if we're going to be starting to use different models, the amount of processing power required on the back end may actually increase at the same time. So all of these multiply together, and it becomes a pretty complex situation where you're thinking about, how do I land this small piece of emerging tech into something that's moving pretty fast? You could be deploying weekly, monthly, what have you, and trying to fit a release like this onto your release train may take some careful planning in order to get things out there. But all this to say, we're here to help you monitoring your large language models, but I do want to talk a little bit about some background. So when we think about LLMs or LLM observability, the question is, what are we actually trying to address? So since the release of large language models, generative AI has quickly become more integral to aspects of business, finance, security, research, and language more than ever. For example, with the adoption of LLMs, we've experienced a significant boost running LLM applications in production, but this has proven to be more challenging compared to traditional ML applications. So for example, you may be used to running Hadoop or other data lake solutions, or perhaps used to EMR in the AWS stack. These solutions that you had in the past may have different trade-offs or pros and cons, for example, than deploying something like an LLM, which in some cases can feel like a black box. So it's something where you put inputs into and you receive output, but you're not sure quite what's happened inside of the black box, inside of that model, in order to give you that answer. But LLM observability provides tools, techniques, and methodologies to help teams manage and understand LLM application and language model performance, to do things like detect drifts or biases and resolve issues before they have a significant impact on the business or end user experience. So, for example, with the Datadog SageMaker integration, you can access more resource metrics, including CPU, GPU, memory, and network usage data for all of your training and inference nodes. Plus, the SageMaker out-of-the-box dashboard, which we have a preview of here, will provide error, latency, and throughput metrics for your inference requests so that you can spot potential bottlenecks. Also, to complement those models from open source organizations, AWS has also launched generative AI services as part of their efforts to make AI more accessible to everyone. Now, this will enable developers to build and scale Gen AI applications by providing API access to LLM foundation models from AI 21 Labs, Anthropic, Stability AI, as well as Amazon themselves. And with Datadog's integration with Bedrock, you can gain visibility into Bedrock API performance and usage. So these are just a couple of the integrations that are a bit more topical for what we're talking about today. But I think, David, perhaps you've got a little bit more information about what's happening on the AWS side.
Absolutely. Thanks, Ryan. So I'm going to talk a little bit about our generative AI stack, as you can see here, as well as the offerings that we have on AWS to support our customers who are building generative AI workloads. So I'm going to start from the bottom here and work my way up. So the first thing to know about our lowest tier of our stack here is at this level, this is the lowest level that our offerings provide to interact with machine learning in general and FMs and LLMs. So at this level, you may be familiar with a service called Amazon SageMaker. Ryan talked a little bit about some of the metrics you can collect there. But at this level, this is where our customers are building and training and tuning and hosting their own models. So if you have your own custom data to bring to fine tune a model, or even if you're building LLMs from scratch, SageMaker is the place to do that. And you can see here we have some additional components. I'm not going to focus on those in depth today in the interest of time, but we do have purpose-built compute for training and inference use cases. And now I want to shift up to the middle layer here and talk a little bit about Amazon Bedrock and this middle layer of our stack. So at the lowest layer, we have the tools to build, essentially from scratch your own models and host them. At this middle layer, we're really providing tools to interact with LLMs from AWS and third parties through Amazon Bedrock. So Amazon Bedrock is a service that provides you an API and various tools to interact with a range of large language models so that you can choose the one that best meets your organization's needs. So here you don't have to build and tune your own models. You can provide some, extended fine-tuning data to extend the capabilities of these models. But you can also leverage base out-of-the-box LLMs, again, from AWS and third parties. And here you can see some of the features, including guardrails, which help you secure and provide safe generative AI applications. So you can do things like harmful content filtering, PHI removal, PII removal, that sort of thing with guardrails. We also have agents, which provide you access to backend business logic through the LLMs that you're using. And as I mentioned, we have some customization capabilities as well to provide your own organizational data on top of these existing LLMs for your use. Now, at the top level here, we're continuing to reinvent here at AWS and listen to our customers' needs. And one of the things that we noticed consistently from customers is that there's a need for tools to quickly access your organizational data from a generative AI assistant perspective. And so here we have Amazon Q. We have a couple iterations of Q, which I'll talk through here, but you can think of Q as your generative AI assistant to help you more easily process and understand your organizational data. So first we have Q Business, and that does pretty much what I just said here. You can connect to your organizational data stores, index those, and provide an application experience for your business users to leverage that data more effectively. We also have Amazon Q Developer, which you may previously be familiar with as Code Whisperer. But Q Developer provides a suite of coding tools, as well as security recommendations and learning opportunities for developers in their IDE. Now, Q also integrates with other tools on AWS, including Amazon QuickSight, where you can not only ask natural language questions about your data and get natural language responses, but you can also generate visualizations in our QuickSight BI service with natural language. So you can describe the visual that you want to create and have that created directly in the QuickSight console. We have other integrations as well as including Connect and supply chain.
Very cool.
So I'm going to take a little bit of a closer look here at Amazon Bedrock next. And I mentioned some of these things, but it's important to talk about some of the use cases and reasons you might choose Bedrock compared to Q or compared to something like SageMaker. And like I mentioned, Bedrock gives you the choice of some of the leading foundation models out there right now through a single API. So you can make a call to Amazon Bedrock and access models, again, from not just AWS, but also Anthropic, Meta, and other names that you're familiar with. Like I mentioned, you can also fine-tune these models for further customization, so you can incorporate your organizational data on top of these existing foundation models. And there's also built-in capabilities for retrieval augmented generation, where maybe the model, the answer or the response from a base model is just not what you want to provide, and you want to rely directly on that organizational data. And in that case, you would use this retrieval augmented generation approach that I hinted at earlier, where you index that organizational data and then set up a retrieval process to return that as a response from a call to Bedrock. And so that that RAG approach, as we call it sometimes, is built into Bedrock directly with a feature called knowledge bases. You can also build custom implementations if you'd like around the Bedrock service. Agents, like I mentioned, this connects you to your backend business logic. So you're able to perform multi-step tasks with agents and string together things that are more complex than just a simple prompt to an LLM can provide a response to. And most importantly, security, privacy, and safety. These are our top priorities. Security in particular is a top priority at AWS. And we have built-in capabilities in Bedrock to help you protect your data, but also protect your users and do things like filtering content, like I talked about. So here, we won't go through every single one of these, but it's important to note with Bedrock, you have your choice of a range of large language models from both AWS as well as these third parties that you see here, including AI21 Labs, Anthropic, Cohere, Meta, Mistral, and Stability AI. So you have not only text generation LLMs, but you also have image generation LLMs, multimodal models as well. And the great thing about this is with model evaluation capabilities in Bedrock, you can easily compare the outputs of these models to choose the right one that meets your organization's needs.
Gotcha. Now, multimodal, does that mean sort of like text, speech, and images, or what does that entail?
Yeah, multimodal more broadly means a combination of input types. So it could be text, it could be images. Mostly here we're talking about text and images.
Gotcha.
Yep.
Very cool.
All right. So next, I want to talk more about Amazon Q when you might choose this service compared to something like Bedrock or SageMaker. So again, this is at that top layer of our generative AI stack at AWS, and Q provides applications for your organization to leverage and easily configure with your organization's data. So like I mentioned, we have Q Business, which is that real business component that provides direct access to your organizational data and documents through a chat-like interface or application. And I think maybe we should go ahead and just jump forward to the next slide, and I can talk about each of these components here. So we have the Q business aspect. So this is great for relying on your organizational data to do things like not only find the information, right, but also summarize it, create new content from that data, as well as extract additional insights from it as well. So I mentioned some of these other integrations as well. So there's Q and Amazon QuickSight, where you can build your visuals with generative AI. You can also do things like create executive summaries and data stories. So a narrative around your data to share with stakeholders and gain better insights into your data on top of just the visuals available in QuickSight. We also have Q Developer, like I mentioned, and Q Developer, again, you may have heard of it as Code Whisperer, but this integrates with your development environment to do things like generate code, create unit tests, perform security scans, help you troubleshoot broken code, and even just help you learn about your code base. And then finally here, we have these specialized use cases where Amazon Q can be used in our Connect service as well as supply chain service to extend the capabilities of those services with generative AI. All right. So, now I want to quickly talk about how do you get started? We've talked about what these services are. Hopefully, you are starting to see where your use cases might fit in terms of our generative AI stack here. And the first thing to do is select the right use case. It's important that your business and technology teams align and try to prioritize the most impactful and also the most feasible use cases for a generative AI workload. So the next step here is to empower your teams. So it's important to make sure that especially your technical teams are trained, but also your business teams are aware of the capabilities of the tools that your project is going to provide. So a quick shout out to our training and certification team at AWS. We provide a large range of opportunities for our customers to learn more about our services. And there's a lot around generative AI there as well. So I want to encourage you to connect with your AWS account manager and learn more about those training and learning opportunities that are available to you.
That's awesome.
And also, step 3 here is to actually get started on those top use cases. So, there are a number of ways you can do this. I think one of the best is to align with your AWS account team and work towards a proof of concept. That account team can help you understand the scope and impact of these use cases. And when you align on those, you can build that proof of concept, demonstrate that value to the organization, and then you can align the right business and technical stakeholders and build an executable roadmap to get that workload into production. So that's all something that the AWS account team can help you with to make sure that you're on the right path to production. And in just a second, I'm going to pass it back to Ryan for a demo, but first, I want to talk about some of the recommendations we have around making use of generative AI in your organization. So we work with a range of customers who are implementing generative AI for various reasons in their organizations, and we see some common threads across these deployments and the ones that are successful, especially. So the first is to understand that generative AI is moving along rapidly. And this is the year of moving from proof of concept in generative AI to production, but it's still a technology that's in very early stages. So building a company culture for continuous experimentation is going to be critical to being able to evaluate different models and understand how generative AI can actually drive your organization forward and help you meet those business goals. Also, it's important to prevent early dependencies in this space where you might be relying on a few selected AI product offerings. With something like Bedrock, you have the flexibility to continue to call the same API and access different foundation models. So that's, that flexibility is important, which brings us to the next topic here. Flexibility is key. Having that continuous innovation and continuing to improve your generative AI tools requires flexibility that's free from technical or contractual lock-ins. And, and having an underlying scaling cloud infrastructure, supporting third-party generative AI integration and a breadth of services helps you to ensure long-term flexibility and deliver business value in a fast-changing environment. Next, no one size fits all. So I mentioned I work with nonprofit customers, and even in that space, we see an unimaginably wide range of use cases for generative AI. And so it's important that when you go into these projects, you think about generative AI as an enhancement of your application landscape and workflows, not a replacement. So requirements in enterprise also differ based on the financial resources, the security needs, the governance controls that you need to have in place, as well as the technical teams that are available to the organization. So having an understanding of that scope might direct you towards one of those layers of the generative AI stack over another. But it's important to keep in mind, what your organization can do in terms of finances, security needs and governance, and even just the skill of your team. It's also important to evaluate buy versus build scenarios in depth. And again, there's no one size fits all solution here. Both options are incredibly valid. So it really just depends on your organization and what the landscape of your organization looks like. And finally, listen and enable. So we encourage our customers to work backwards from their end users or customers and listen to the experts in the space and enable employees with the right set of tools. Something from our generative AI stack is going to be very flexible. And also, again, with those training and certification options, as well as the learning opportunities available from AWS, that really combines to make sure that your teams not only have the right tools, but they're also equipped to use those tools. So these are the big aspects and big takeaways that I want to encourage our customers to consider as we're going forward. And the last note, of course, not on this slide, but pertinent to this talk in particular, is the importance of continued monitoring and observability of your generative AI workloads. So having a deep understanding of the internals of your applications and making sure that everything is running smoothly, that your users aren't experiencing performance issues, and even just understanding things like how many tokens your users are supplying to an LLM on average really helps you better understand the users of your application and helps you make improvements that are actually beneficial to those users. So with that, I'll pass it back over to Ryan.
Yeah, thank you very much. I mean, this slide is great. I think it sort of gives you a bit of an overview of like what to know before you go, essentially. But I really like the fact that you're talking a bit about experimentation. And I think when we're talking about emerging tech, the experimentation is kind of the name of the game. I say this because if you're thinking about a science experiment, one of the big things involved is measurement. So trying to figure out how you started and maybe what your outcome is, and then measuring your results to see how close you are to it. LLM observability is no different than this in terms of the actual like monitoring or observability from before. So I guess you could think of our four golden signals like latency, errors, traffic, and saturation, and those loosely apply to LLM observability, and I'll talk about why. The other thing that David mentioned that I just want to sort of take as an aside is the security of these models. And when I say security, I guess I mean it depends on the use case that you have. Say it's an internal tool, a chatbot, that kind of thing. It may not be the security in that aspect is as important, but if, as David mentioned, you're going down like a RAG application where you've got company data added in, you want to ensure that when you return the company data, that it's accurate. And that is one of the things that as you're going along in either training your model or adding more embeddings to it, that is to say like ways to look up that information that you've got in your private repository prior to calling the model in order to retrieve it, those can be little tunables that will actually allow you to give more accurate results, but also more secure results in terms of the way that they're returned. So we'll talk a little bit about how to measure that first. But the first question here, and sorry, this is all in big text, but basically it's we'll talk about like what is it? So because LLMs have become so pervasive, let's say, in terms of things that people are trying these days, generative AI has quickly become more integral into aspects of business. Now, when that happens, say in finance, security, research, and language than ever before, you want to start thinking about, okay, how do I monitor this then? If it's now on the critical path to my production application, what do I need to do to ensure that it's working properly? Now, there's a quick quote here, but while the adoption of LLMs has experienced a significant boost, running those applications in production, has proven to be more challenging compared to traditional ML applications, as I mentioned before. One thing that can be important is managing those LLMs will now require continuous monitoring in order to guarantee sustained performance and security while producing those precise and unbiased responses, as we were mentioning. This is a quick overview of our product, basically. But when you're thinking about what you need to address in terms of how you get it out there, you want to think about the tools, techniques, and methodologies that will help teams manage and understand LLM applications and language model performance. That's to detect risks, biases, resolve issues before they have a significant impact on the business or end user experience. Now, I realize I repeated that almost verbatim from before, but it does need to be underscored that that is your goal. So as you're starting to manage this emerging tech and putting into something that's already existing, you want to make sure that it lands properly. Now, For most of this, we'll be talking about like a dev environment, but David's right. This year is the year that people are starting to now roll this out into production. And when you think about production readiness, there's a lot of, I like to call them gates or hoops basically, but there are things that you need to jump through prior to getting to production that will ensure that your production environment remains as stable it was before, as secure as it was before, but also can provide answers to your clients that are valuable. And that's kind of what we were getting at before. So a proof of concept is great, but your main goal is to provide value. So what does that proof of value look like? How can you make sure that when you test something new, when we're changing models, let's say between something that Amazon has in-house or maybe an Anthropic Claude model, for example, you can look at one, like the tokenization that we were talking about before is how many tokens are you sending? What does the cost look like? But also the reliability or the biases in your results. So it could be that different models allow you to give different answers for different questions as well. So it might be something where you're looking at a chain of models. So if it's a code question, for example, maybe you go to one model. And if it's more of a natural language processing question, then you go to a different model. And this becomes pretty complex pretty quickly. As you've noticed, there are quite a few models that AWS alone can serve you. And the question is, where does that go? How do you filter through them? What does that trace look like? What does that decision tree look like? And which models ended up being used in an answer? It's pretty important when you're looking into that black box and trying to monitor it. Now, apologies for all the red here, but I did want to underscore that there can be issues that, not to scare you away, but we talked a little bit about hallucinations. That's to say, so we asked the model a question and it didn't find any results. So it generated something that it thought, and I'm personifying here, which is the danger with LLMs, but that the model may have assumed was useful for the question that you had, even though it's completely unrelated or maybe as less use than you thought. So some of these issues are things like because they're in their infancy, there are a number of issues that can occur. These can be prompted by users, but also within the LLM's responses on its own. So a proper LLM monitoring tool can help organizations keep track of these issues that might occur within those LLM enabled applications. So we mentioned hallucinations, but there's also performance and cost. So especially in something like a RAG application, if you're not careful with your embeddings, it could be that the tokens that you're sending for every request could be quite large. On top of which, you may be affecting your latency because the amount of data that you're sending back and forth is large. And as a result, sending that large data back and forth can cause the latency of your application to increase. So that's to say, if I ask a question, perhaps it takes 4 seconds to get an answer instead of one. And I'll cover that a little bit in my demo, but basically this is a real world use case. The next is prompt injection. Now, just a quick overview of prompt injection. It might be that you're injecting something into the question that you're asking the model, or maybe the API request that you're giving to the model, in order to subvert a little bit the answer that it will give back to you. And you've probably seen these in the field, but basically the question is, how do you detect these? And maybe find bad actors, or perhaps do something like rate limit requests so that they're not taking out too much of your request to the API in the back end. Furthermore, we talked about security and privacy. This is no stranger to a lot of people in the DevSecOps space or the DevOps space, but of course that applies here as well. And then finally, response variants. So we talked a little bit about different models having different answers, but there could be different versions as well. Or if we're talking about embeddings or maybe different techniques that will give you different answers depending on the way that you've embedded your data. Okay, just to quickly dive into these, I won't take too long on each one, but just in case. So sorry, this is again a bit of an eyesore, orange on red, but basically hallucinations, to sum it up, basically LLM-powered applications may occasionally produce false information. So this phenomenon is called hallucinating, and particularly when confronted with queries for which they don't possess an answer. So for example, if David, we trained you as a model on recipes, and then I asked you to give me like a trip estimation between cities, it could be this completely unrelated. And as a result, because the model doesn't have that information, or David's mental model doesn't have that information, he may give me something that he thinks is different, or sorry, that he thinks applies, but is actually different from the answer that we're looking for. And it can be difficult to track these unless we know how to test basically that drift, or to see what happened in the answer, if it's related or unrelated. In some cases, this could be one model processing the data that's output from another model to see how likely it was to answer the question. And it might be something that you've added to like a CI/CD process. So as you're adding in new models or testing new models or new versions of software, it could be that the hallucination go away or become more apparent. And this is something that you want to track as you go because this is going to affect the quality of the results that your users are getting. All right, so rather than acknowledging their lack of knowledge, they frequently will yield responses that may appear assured, so confidently incorrect, but are essentially flawed. So this propensity can potentially foster and spread inaccurate information, and this consideration is crucial when applying LLMs to activities that necessitate factual accuracy. So we were talking a little bit about healthcare usage, for example. So if we're thinking about PII, making sure that when we add data to the RAG, that it's not giving us things that are sensitive, of course, but also when we're talking about factual accuracy, let's say we put charts in the model, for example, and that we're pulling up medical records, we want to make sure that the records that we're retrieving are in fact accurate and for the patient or patient number that we're pulling up. Again, I've contrived this example. Perhaps this is not the best real world use case, but when you're thinking about things internally, like standard operating procedures, that kind of stuff, or branding guidelines, you want to make sure when you ask your LLM for information about these topics that the information that you get back is in fact accurate. All right, spent a little bit too much time on this one, but this one's a little bit easier. So performance and cost. So often the applications built on LLMs rely on third-party models. So we talked a little bit about the ones that AWS hosts, as well as the first-party AWS models. That dependence can lead to issues such as performance degradation of those third-party APIs. So for example, if you weren't using something like a hosted solution, and perhaps you're hitting a public API that a lot of users are using, it could be that the degradation of the API has little to do with your application and more to do with the external API, so the performance can suffer. The nice thing when we're thinking about buy versus build here is when you're dealing with a partner like Amazon who has these set up for you, they can elastically expand the capacity for the API requests as opposed to something that's shared. Furthermore, if you're managing this on your own, I don't know if anyone's done this before, but these models can take up quite a bit of memory. And depending on the amount of people that you've got concurrently asking questions or sending API requests to the models, they can bog down quite quickly. So it's important to be able to elastically respond to this. Now, on top of this is when you've got a large group of users, a corpus of users who are asking many questions of your model, it could be that your performance degrades mostly because your application is in front of it, causing a lot of requests to go to the model. But one of the things that can output from, or sorry, an outcome that can output from this is the cost of the actual request can increase. Now, this isn't to say that any model is more expensive than others. It's more about the amount of tokens that you're sending to the model, regardless of the model that you're using. It could be something that you want to take track of. David mentioned, for example, what is the median or average token request for a typical query. That can become an important metric for you as like a proxy for how much it will cost to call the API. All right, and basically this particularly applies to large data volumes, which is why we're talking about retrieval augmented generation. Here are those RAG stacks. Now, I mentioned this a little bit, but prompt injection is a technique where users can influence the LLM applications to produce specific content. So for example, this manipulation can potentially cause LLMs to generate inappropriate or harmful material, which we don't want your users seeing. So awareness of this issue is vital, particularly when deploying LLMs in those customer-facing applications. And finally, we've got security and data privacy. So those LLMs pose new security issues and can, including, as mentioned, potential data leaks, so PII or PHI, output biases due to skewed training data, and risks of unauthorized access. Additionally, LLMs may generate a response containing sensitive or personal data, and because of that, stringent security methods, and ethical practices are vital with LLMs. All right, sorry, I lied. There's one more. So the model prompt invariance response can basically say, like, if I ask them all the same question multiple times, we would expect the answer to either be exactly the same or very similar to the result that we saw previously. Now, I'll show a pipeline that does this in one of our demos, but imagine, if you will, that an hourly question that asks, what color is the sky, or why is the sky blue, or why is water wet, that kind of thing, and you ask it on a regular basis. These are pretty common questions to ask the LLM, but you'd expect the answer to be the same or similar. When you change models, this may not be the case. In fact, when you change versions of models, it may change as well. So the user prompts received by the LLMs and the response that they generate can vary in attributes such as length, language, and accuracy. Users may also receive different responses to the same query, which is unideal, and that may lead to confusion and inconsistent user experience. And finally, this enforces the need for continuous monitoring and logging of LLM applications, which we'll talk about now. So what are the benefits of LLM observability? So if I'm observing this entire pipeline or this black box, what do I get out of it? So as the tools rapidly evolve, organizations that implement in-depth monitoring of their applications can expect these benefits. So you've got improved performance, which is the LLM observability enables real-time monitoring of various performance evaluation metrics, such as those latency, the throughput of the traffic that we talked before, and the quality of responses. By continuously monitoring these metrics, data scientists and engineers can quickly identify any deviations or degradation in LLM performance. And that proactive approach allows for timely intervention, leading to improved model performance and user experience. Now, next we've got better explainability. So basically, when we talk about this black box, it can be hard to reason about what actually happened, particularly when you have a chain that includes multiple models. So with LLM observability, you get deep model insights into inner workings of LLM applications. By visualizing the request response pairs, word embeddings, or prompt chain sequences, LLM observability enhances the interpretability of responses. So this increased transparency enables stakeholders to trust LLM applications' decisions and identify any quality issues or errors in the application's output and logic. Finally, faster issue diagnosis. So when there are problems, what do you do? Basically, end-to-end visibility into the operation of an LLM application is essential to resolve issues such as no or incorrect responses. So I'm not sure if anyone's seen this before, but when you ask a model for a question, sometimes you can just get like a response, a 200 OK, but it's a blank response. So it's a JSON that contains nothing, for example. LLM observability enables engineers to analyze the back-end operations and API calls for a request to pinpoint the root cause of an issue, reducing the time it takes to resolve that issue. Okay, and security, of course, is pervasive here, but LLM observability plays a crucial role in enhancing the security of LLM applications by monitoring model behaviors for potential security vulnerabilities or malicious attacks. By tracking access patterns, input data, and model outputs, LLM observability tools can detect anomalies that may indicate data leaks or adversarial attacks. And this is when we're talking about people putting in prompts that may maybe crafted in a way where they're trying to get more data than you would expect them to ask for, or maybe they're novel requests that your model wasn't trained on. The continuous monitoring helps data scientists and security teams proactively identify and mitigate security threats, safeguarding sensitive data and maintaining the integrity of LLM apps. Finally, efficient cost management. Observing the resource consumption and utilization of LLM models allows organizations to optimize resource allocation and costs based on actual usage patterns. By monitoring metrics such as token consumption, CPU, GPU utilization, and memory usage, observability tools help in identifying resource bottlenecks or underutilization. These insights can inform decisions on scaling resources up or down, ensuring cost effectiveness of LLM applications. All right, sorry, that was a bunch of mouthfuls. So basically what we're trying to say is that there are certainly problems with new tech, but there are solutions for them. That being said, this is all emerging. So what I'd like to demo today is something that's in public beta. So I'll deal with a little bit of the ins and outs and how the tool works, but I do want to stress that this may change. So we've had it out for a little bit, but there are some categories here that I'll talk about. But I do want to stress that this is in fact maybe a little bit different than when it launches as a generally available piece of software. So I'm just going to quickly pull over a live graph here. Just give me 1 second. We'll pull this over here and make it full screen. All right, so I showed a picture of this earlier, but this is the LLM observability tool. Now, I'm going to do this live just because I started running some synthetic traffic prior to this recording, but basically what we want to do is explore how the tool works. So we can go top left to bottom right, essentially. But if you haven't used Datadog in a little bit, I just want to quickly go over some housekeeping. So the left-hand side, the dashboard's changed a little bit, but if you're having a hard time finding it, if you press Command K or Control K and then type in LLM observability, you'll find it. Or if you're looking for it on the sidebar, under LLM, and specifically look for the beta tag here, there's a public beta of LLM observability here that you can click on and will load. So every customer should have access to this. already. Now you can see here that this tool has, oh, sorry, I clicked on something by mistake, has quite a bit of stuff going on. So we're just going to quickly minimize and get rid of the sidebar just for a moment. So we've got more screen real estate. Now, top left to bottom right. So we've got traces here, which is what we're going to talk about primarily, but we've also got clusters. So clusters of issues, as well as a dashboard for all of this. What we're going to talk about today is primarily on the traces side, because I feel like that's where most of the value is. Now, at the top, you can see that there's no errors at present, but one of the key things I want to call out here is that some of our answers, or in fact, the P95 duration of the slower answers, so the top 5% slowest queries, is 7.44 seconds, which is pretty slow. Now, this is not to say that Amazon's slow by any means. This probably has to do with the RAG application that we're using, sending many tokens over to the API prior to getting an answer. And this is one of those maybe like common scenarios that David and I are seeing, is that depending on what you're doing, you can have a large explosion of tokens. And because of that, not only does the cost increase, but the amount of time to return all the data will also increase. Now, this means that the user experience can also be slower as a result, which could cause complaints. Now, in this case, we don't have token counts for these just yet, but we can see that there are some unanswered questions as well. So for example, if we were counting our tokens, we could say like maybe these are sending 4,000 every time, which is quite a bit. But also, we've got some that are unanswered. And you can see that there's a little hand icon there. And I call this out because when we're looking down these rows here, if we zoom in, we've got this failure to answer here. And we can see that each of these, so these 41 unanswers, if we filter by those, we'll get all of these as well. And there's a few ways to do this, and I'll go through different techniques here. But basically, we've got quality metrics. So one of those that we're talking about is failure to answer. We've also got the language mismatch. So imagine if I sent in something in English and I got a different answer back, that would be a problem. Or perhaps I asked a code question, but I didn't get a code answer back. So something's actually going wrong. The next is negative sentiment. And this could be that the user is actually sending in something that's, well, let's say a little bit like one of those social media answers, basically. It's a little bit from the hip, a little bit negative in sentiment, but as a result, it may affect the answer that the LLM is returning. Also, we've got the total duration by application. So imagine when we're thinking about end-to-end, what that latency looks like, including the black box in the middle. What does that look like? Now, when we're talking about something like 5 seconds, or if we go up here, some of these are 9 seconds, they're pretty slow. If you think about how long a web page loads, you probably expect it to load under a second. But if you've got like a chatbot that you're asking questions of, and they're answering on a regular basis, maybe 2, maybe 3 seconds from the time it starts to start typing to when you get the full response back, I think that's probably okay, 2 to 3 seconds. I would say though 11 seconds is probably a bit on the slow side. You'd expect it to return faster than that. And again, this could be a problem in our application that we need to drill into to figure out where it's coming from. And finally, just on the left-hand side here, we can start drilling through. So if we just want to show the ones that are different durations, we can do that, no problem. We can see that most of these are okay, so there's no errors in this one here. We can go back a little bit further and do that. We can see that we've only got one application, that's this StoreDog chatbot that's running. And we can also see that in terms of environments, we've only got one security quest running in the back end. But under here, when we talked about these quality checks, for each of these, if we want to only look at toxicity, for example, or only want to look at failure to answer, language mismatch, that kind of thing, we could. And similarly, if we just want to look at security or prompt injection, same thing. So we can click on only, and it will bring up all those ones. Now, you'll note that there are some decorators here. So these icons, it could be that there's multiple things going on at once. One thing that I think is pretty handy is instead of this default view, if you go into reader view, you can actually see what's going on here. On top of which, if we click into one of these, we can actually see the trace of what happened. So we can see that we actually called Anthropic Claude Instant V1 with Amazon. So it's a different type of model. Perhaps we picked the wrong model for these types of questions. Maybe we did it on purpose. So we can see what the input is here, and then we can see the output. So in this case, we're trying to do social security numbers, which is probably not something we want our model answering. Also, we can see that we're asking this question on a regular basis, and that can tell us if there's any drift. So if it starts giving us SINs or security, social insurance numbers, this could be a security problem. So what we want to do is track this over time. So this could be something that we schedule, or maybe we run in the dev environment as we're going through iterations of different models or different versions of models. And finally, as we go through here, we can go from left and right. We can look at quality checks, for example, to see what was going on, as well as security and privacy. And then we can look at errors if there are any others. Now, we're looking at what we call the root spans here, but we can also look at all of the spans. So if there's a span that includes others, we can do that too. And this is important because if you want to drill down specifically into how your chain was used, for example, this will give you better insight into what actually happened the whole way through. So if we go through, we can actually see that this one's just a review and generate trace, but we could actually pull up the entire trace of the code here. All right, so that is it for my demo. But basically, we've got some resources and slides here that I'll try to bring up. Just give me one moment.
All right, everyone. We wanted to leave you with a few resources to help you take that next step and get started with LLM observability with Datadog and AWS. The first resource here is a link to Datadog's Knowledge Center, where you can learn more about common challenges with LLM applications and the benefits of LLM observability. Next is a blog post on how to effectively monitor Amazon Bedrock API performance and optimize your LLM usage with Datadog. And finally, the QR code here links to the Datadog offering on the AWS Marketplace, where you can get started with all the features and capabilities of Datadog with a 14-day free trial. On behalf of Ryan and myself, we want to thank you for spending the time with us today to learn about LLM observability. If this has you excited to learn more and take that next step, be sure to visit these resources and don't hesitate to reach out to your respective teams at AWS and Datadog for more. Thanks again for joining us. Until next time.